Good morning, everybody. It's such a pleasure to be here today. We were joking backstage, like, what does AI stand for? So I've been on this mission to humanize technology before it dehumanizes us by bringing emotional and social intelligence to machines. AI is ingrained in the everyday aspects of our lives. It's becoming mainstream. It's become mainstream. It is taking on roles that were traditionally done by humans. Everything from being your health advisor, your learning companion, maybe it's driving your car, helping hire your next coworker. And let me ask you all a question. How many of you have played around with ChatGPT or GPT-4? Many of you. And you can tell that it can do a lot of things for you. You can delegate it all sorts of tasks. So yeah, AI is becoming mainstream. The problem is the focus of everything AI today is on the IQ of the AI, the cognitive intelligence. And nobody's really thinking about the emotional intelligence or the social, kind of the human-centric elements of these technologies. And that's a problem, because we're spending so much time with these technologies, but they're completely blind, emotionally blind, and have very little context about how we behave and why we do what we do. So emotional intelligence is the missing element, and we all know from our lives, our personal experiences, that your EQ matters sometimes even more than your IQ. The best leaders in here are the ones who are emotionally intelligent and can tap into that emotional experience of their team members. We can be more persuasive, we're better partners, we're better leaders with EQ. So that's a problem, and we are entering dangerous territory. We've all seen in the news examples of AI hallucinations, bias, and these technologies just giving us bad advice. So I'll share some examples. And this problem isn't new in AI. It's been around for several years now. In my space, where I do a lot of work with quantifying facial expressions and emotional experiences of people, there's been a lot of criticism in the news of big tech and their facial recognition technologies being trained on a very non-diverse set of humans, and so if you then run it on somebody that looks like me, it just doesn't see my face. So that was one example. A few years ago, Microsoft released a chatbot on the internet. It actually had done really well in China, but then they wanted to bring it to the US. It learned from people's Twitter kind of dialogues, and it became racist within 24 hours, and they had to pull it down. We've all seen, this is more recent, Kevin Roose's New York Times article where he engages with ChatGPT, and it very quickly convinces him, well, I don't know if it convinced him, but it very quickly suggested that he's in a bad marriage and he should get out of it, and it was in love with him. And they've taken care of that kind of experience on ChatGPT, but still very concerning. And then much more seriously, this is not specifically ChatGPT, but it was a tool released in Belgium. This guy was using, he called the bot Eliza, and he was asking for advice on how to commit suicide. And initially the bot said, well, I can't tell you that, you should seek help. He changed the prompt just a little bit. And you can see it gave him suggestions, like 5 different ways he could actually do that. And unfortunately, the guy did end up committing suicide. His wife got access to the text threads, and it's now in the public domain. And who's responsible? Who's accountable for this kind of bad, irresponsible advice? Another example, this lawyer was representing a client who was doing an airline, and he used ChatGPT to create the brief, a 10-page brief, and then the judge kind of goes through it, and it's all hallucinations. It's not even accurate. The cases referenced are not real. So again, who's held accountable for all of this? Even my son, he's 14 years old, and he's been experimenting with all these technologies. He's actually my teacher when it comes to some of these new tools. And he very quickly learned that yeah, some of these sources that are generated by these technologies are just not true. And it was a great learning moment because we had to think through, okay, what is the intuition behind how these technologies work and why do they, on the one hand, it can be very useful as a creative tool, but if you're using it for discovery and fact-based truth, it's not that accurate. So the technologies are developing way faster than we're able to fathom how to handle them, especially as it relates to ethics and safety. And so we have to really think about this contract we have between humans and machines. And this contract has to be based on empathy, because empathy is at the core of how we make a lot of our decisions, and of course, trust. Yeah, so what does the social contract look like? Actually, different companies have different approaches. So for example, NVIDIA and Microsoft talk about AI as being your co-pilot, or your cobot in the case of a robot. But is it really? A co-pilot implies kind of equal responsibilities. You can literally, as a co-pilot in a plane, you can go to the restroom and the other pilot takes over. But that's not really the case with AI. And we've seen examples where, for instance, the Tesla co-pilot, you can't just rely on it for driving. So the naming kind of can be misleading. Is it a smart intern? I've heard that analogy, and I think that's an interesting one. You can delegate kind of, delegate tasks the way you would to a junior intern. And then I remember having a conversation where it's like, well, what if the smart intern gets really ambitious and wants your job? And then maybe that's not a bad idea. Let the intern take, let the AI take my job. And then how autonomous should AI be? And how tied to human will and intention should it be? The way I like to think about it is it's just a tool. It's here to augment our intelligence and make us more productive, happier, more connected human beings. A little bit about my background. I grew up in the Middle East. I'm originally from Egypt. Both my parents were in technology. They actually met because my dad was teaching a COBOL programming class. COBOL is an obsolete programming language. This was back in the 70s. I'm hearing some chuckles. Maybe some of you know it. Yay, COBOL. And my mom signed up to take this programming class back in Cairo. And they met, moved to Kuwait. We were there during the first Gulf War. But I remember growing up kind of exposed to all these new technologies. And the thing that struck with me the most is how technology can bring people together. It brought our family together in very interesting ways. And that's been a thread throughout my journey. How can we leverage technology in a way that brings people together? So from then on, I studied computer science as an undergraduate, really wanted to be an academic, so went to Cambridge University, pioneered this field of artificial emotional intelligence, or emotion AI. And the origin story there is I get to Cambridge. It was my first experience being away from home. I was actually a new bride. My ex was still back in, well, he's my ex now, but my husband at the time was back in Egypt. And I just remember that I had all these emotions that I wanted to communicate, and the best I could do was send a text with an emoji. And I felt like all the nuances of our emotional experience disappeared into cyberspace. And so that set me on this journey to understand, like, how can we capture these emotional experiences when we are communicating and connecting digitally? It turns out only 9% or 7 to 9% of how we communicate is in the actual choice of words we use. The vast majority is nonverbal, and it's split equally between your facial expressions, your hand gestures, your body posture, your vocal intonations. And so a lot of these signals basically disappear when we're connected online. We don't capture that data. And so I've been on this mission to capture these new nonverbal signals. I focus on the face. That's where I got my start. The science of facial emotions has been around for over 200 years. This guy, Duchenne, used to electrically stimulate facial muscles. Thank goodness we do not do that anymore. And then Paul Ekman and his team in the 70s published the facial action coding system, which maps every facial muscle to a code. So for example, when you smile, that's action unit 12. If you furrow your eyebrows, that's action unit 4, and so on. It takes about 100 hours to become a certified face reader. You have to go through all this training. And then if you want to code a video, you have to play it in slow motion. It takes about 5 minutes to code 1 minute of video. It's so laborious and time intensive. So instead, we use AI, we use machine learning and tons of data. So at this point, we've got, gosh, over 15 million facial videos of people responding to all sorts of experiences and content. And we use this data and deep learning to essentially find, okay, what's common between all the smiles? What's common between all the eyebrow raises? What's common between the frowns? And the system learns these emotional expressions. When we first started, the algorithm could only detect 3 emotions, and now it has a repertoire of over 40 different expressions and states. It can do things like activity detection and behavior detection, and it can detect if you're tired or, excited and sentimental, so all sorts of states. And it's basically a function of what kind of data can we get access to and feed to the system. It's really powerful. And we're now at a moment in time where, we kind of incorporated deep learning into our tech stack, I'd say about 2014, 2015, and now we're kind of reevaluating whether we should migrate our entire tech stack to generative AI. We're still not there yet, especially because we do a lot of video work and it's very compute intensive, but I do believe we will get there at some point. So after my PhD, very serendipitously towards the end of my program, I met this MIT professor. She invited me to join her lab at the Media Lab at MIT. And we did a lot of research applying our technology to autism. And I'll circle back to autism at the end of this presentation, where we help individuals on the spectrum understand these nonverbal signals. But in doing so, and being at MIT, we were very connected to industry. And we very quickly realized that there was a unique commercial opportunity in this technology. And so we spun out of MIT. This is Rosalind Picard, my co-founder, and the MIT professor who really did change the trajectory of my life. I was supposed to go back to Egypt and become faculty there, and instead kind of moved to MIT, and that kicked off kind of a whole different alternative universe. So when we spun out the company, this is back in 2009, we wanted to avoid the word emotion at all costs. So we called the company Affectiva. If you look at our initial pitch decks, we never talked about emotions. We were mostly pitching to an older white men investor community, and it was we recognized that we looked very different from their typical kind of founders. We were 2 women scientists pitching an emotion company. So we called it all sorts of things like sentiment and valence and arousal detection, and we never talked about the word emotion. And then, a few years later, we decided to embrace that. We coined the term emotion AI. It's now a category within the AI space. And 2 years ago, we joined forces with a publicly traded company called SmartEye. They're very focused on the automotive industry, and our vision together is to bridge this gap between humans and machines. So often when I present this technology, people think that it's out in the future and it's going to be deployed in the world, in the next 5 to 10 years. It's not. It's already here. And so I wanted to share some examples of where this technology is being used today. So first, we can understand and we can quantify people's emotional experiences, especially as they engage with content, products, and services. We can quantify moment by moment that experience. And that data can be very powerful. So today, over 90% of the world's largest advertisers and 28% of the Fortune Global 500 companies use this technology to understand the emotional experience their consumers and their users have with their content. The way this works is you would get a kind of a link to a survey. We would ask for your permission to turn the camera on while you're watching a piece of content. Consent is very important to us, so you have to consent. And usually there's a value in return for doing that. Often it's you get paid to watch this piece of content. All right, so what we do is, again, cameras turned on. We ask for people's permission to kind of identify their expressions, and at 30 frames a second, we're able to read your emotional facial expression. And we aggregate all that data anonymously, and we basically get kind of a line graph. This particular one is just the smile expression. We have 40 different states that we can track. And you can see exactly where people were smiling. And we found that this kind of emotional journey versus like a lot of the shampoo ads we test, which are just like flat emotional states, the more kind of an emotional journey you can create, the better this is tied to purchase intent, actual purchase behavior, and virality. And what's really cool about this one is we sometimes test for wear-out effects, like do you remember this ad if you see it again, which is the dotted line here, and you can see that people are anticipating the funny parts of this ad. So that's amazing. We don't often see that. But it doesn't just have to be this kind of content. It could be educational content. It could also be meetings. So there's a company called Read.ai, but there's several of them, where they are able to quantify meeting dynamics. Again, you're on a Zoom call or a Teams call. We can already see people's faces. And with their permission, we can quantify, again, these interactions. And it provides real-time insights into sentiment, level of engagement, speaking time, which is really interesting. These guys have found that men dominate as much as 75% of the conversation during conference calls, which I thought was really interesting. So it can quantify data that has never existed before, and that provides for unique insights and action. A company called Udly kind of turned it on its head a little bit, and they use these kinds of metrics to help coach people to become better managers, better speakers, better negotiators. For example, it can, if it's recording this talk, it can say, well, you said X number of times, you're not making enough face contact or eye contact with the audience, so it can give you like very quantitative insights into how to interact with other people. And then moving on from this idea of like measuring people's experiences, how can you use this data in real-time interactions? So one of the areas that we spend a lot of time is in the automotive industry. And the idea is having an emotionally intelligent vehicle, especially when it's semi-autonomous, that has your back. And when we first started doing work in this space, the first question we had was like, okay, when people are driving, are we even going to see anything, right? Like, is there going to be any movement on the face, any interesting data? And so what we did is we sent people out with cameras in their cars, and we said, again, in return for some comp, can you install this camera in your vehicle, and we'll just record your daily commute back and forth. And we have permission to share a couple of videos, so I'll do that. And again, remember, these are people. This is actually, this is quite, there are about 4 levels or degrees of drowsiness. This is an extreme level of drowsiness. He's basically asleep. We can track that very easily because of the eye closure patterns and also the head bobbing. And then we can also track that his young daughter is in the back seat. So it's very dangerous, but it's a great example where the car can detect this in real time and intervene. Here is another example. So she's texting while driving. I do not want to be driving next to her, but yes. So hands are off the wheels. We can detect that. Eyes are off the road. We can actually also do phone detection and object detection today. So we can detect that there are not 1, but 2 phones in her hands. Extremely distracted driver, and again, the car can basically say, you know what, you're like really not focused right now, I'm going to take over for the next 10 minutes while you do your emails. And the vision is to not just focus on the driver. We're actually moving this camera to the rear view mirror. By the way, we don't record any, this is recorded data because it's data collection, but in deployment, we don't record the data at all. And the camera is kind of migrating to the rear view mirror so that it has a full view of the cabin. We can do things like, are people seated properly? Are they wearing their seat belts? Child left behind is a big safety use case. About 50 or so infants, unfortunately, die every year because they're forgotten in the car. Well, we can detect that so easily. We can detect that there's a car seat and that there's child in the car and text the parents. We can detect like different activities like eating, drinking, and of course the sentiment in the vehicle, and the car can adapt and personalize the mobility experience accordingly. So lots of applications in this space, and I like to think of a car as just a robot on wheels. So everything that we're doing in vehicle can be applied to the robotic space as well. We're seeing a plethora of social robots, and I'll cover a couple of these examples that we kind of are the emotion brain of these robots. But one of the areas where I believe this technology can be really transformative is in the mental health and generally the health space. We know that there are facial and vocal biomarkers of mental health disease. But yet the gold standard is still a survey. On a scale from 1 to 10, how depressed are you? How much pain are you in? How anxious are you? How suicidal are you? And this data is very subjective. It's not longitudinal. It's very hard to get accurate data. Well, if we can, if every time you check your phone or every time you check into an app, it's an opportunity to build that baseline for you. And then if you start deviating from that baseline, the app can flag that to a loved one or a clinician or a therapist, depending on where, depending on the person. So one of the companies that's doing really amazing work in this space is called Videra Health. They have this app that people check in. They create these video verbatims, so it asks you a few questions, you record a video, it quantifies both the language, how you say the words you say, and your facial expressions. And they've been able to literally save young people's lives by detecting at the right time that this person is not in a good space and getting them immediate help. So I love that application. There's a number of social robots out there that are designed to be a health companion. So Mabo is a robot developed by a company called Catalia Health. They're another MIT spinout. And they send terminally ill patients home with these robots. You can't send a nurse or a support person with every patient, but you can send the robot, and the robot acts as a proxy to a nurse. It can help with patient tips, medication advice, medication adherence, and again, it knows your baseline, so it knows if you start deviating from that to get you some help. Moxie is oh my God, where's my voice? Okay, I think it's back. All right, so Moxie is a robot developed by a company called Embodied, and it is designed to be a learning companion for kids, especially kids with social and emotional challenges, like, for example, autism. Thank you. Thank you, Richard. Thank you so much. Thank you, Richard. You saved the day. So again, they're not mainstream yet, but we're seeing a lot of examples of these robots being applied in a number of different applications. And then back to autism, it's where I got my start with this kind of technology. We are partnered with a company called BrainPower. They use Google Glass with our technology embedded in it to help kids on the autism spectrum read and understand these nonverbal signals in a very fun and gamified way. So I will play a video. Oh, let me actually, there we go.
What do you see on screen?
Mom.
8-year-old Matthew Krieger has been diagnosed with autism.
A lot of the trouble he gets into with other kids is he thinks he's funny and doesn't read at all that he's not, or that they're annoyed or angry.
Matthew's mother Laura signed him up for a clinical trial being conducted by Ned Sahin.
I want to know what's going on inside the brain of someone with autism. And it turns out parents want to know that too. You get points for looking for a while, and then even for looking away and then looking back.
Sahin's company BrainPower uses Affectiva's software in programs Matthew sees through Google Glass. These games are trying to help him understand how facial expressions correspond to emotions and learn social cues.
One of the key life skills is understanding the emotions of others, and another is looking in their direction when they're speaking. Looking at your mom, and while it's green, you're getting points. When it starts to get orange and red, you'll slow down with the points.
Am I looking at you?
You are looking at me.
Just a few minutes later, the difference in Matthew's gaze overwhelmed his mother.
I'm going to cry.
Why?
When you look at me, it makes me think we haven't really before, because you're looking at me differently.
So BrainPower has about 400 of these devices deployed across different homes in the country. We're already seeing, as you saw, that the kids, while they're using the glasses, are actually getting really better in terms of doing face and eye contact and recognizing these different expressions. The key question is whether this is a prosthetic device or it's just a learning tool. So if you take away the glasses, have the kids retain some of these skills? And so that's the question they're trying to answer. But this is one of the great examples of how this technology can be transformative. I often get asked, well, should this technology exist? And I am all for thoughtful regulation. I think there are incredible use cases of this technology, especially in health. But at the same time, you know, I'm a pragmatist, and I can see how this could be used to discriminate against people. It could be used to manipulate people, and we have to be very careful. So I'm a very big advocate for thoughtful regulation, and I've been following very closely what the European Union is doing with the AI Act, and I think it's headed in the right direction. So in terms of the ethical development and deployment of AI, we have to think about privacy, we have to think about bias, and one of the best ways to really address some of these issues is by changing the face of AI. Today it's very, very non-diverse, and you know, whatever kind of way you cut it, it's very non-diverse. And I do believe strongly that AI does have the potential to elevate all of humanity, but to do that we need more diverse brains around the table, not just as consumers of these technologies, but as builders of it. So since I've sold the company, I've been spending a lot of time investing in the AI space, and I do believe that the next trillion-dollar company is going to be AI first. And I want to see kind of a diverse set of founders building these technologies, but also a diverse set of investors investing in these ideas as well. And again, more women, more people of color, but also like more globally centric ideas as opposed to just being US-centric. And just to wrap up, this is one of my favorite quotes for as the pace of change increases, not just the economy, but the very meaning of being human is likely to mutate. This is by Yuval Harari. As we see these AIs becoming more not only kind of IQ smart, but emotionally savvy and having empathy or simulating empathy, what does that, and being more creative, right? What does that mean for us as humans? And just to kind of wrap up, for me, this journey hasn't, you know, I am very much steeped in the AI space, and I think it's an amazing time to be in this field. But for me, it's always been about humans and human connection. So human first. Thank you.